Hey guys, so here's the 6.2 day 2 notes. We're now going to multiply radicals. Okay, so let's look at number 7. We have square root of 3 times square root of 6 plus square root of 8. Now remember, anytime you have a monomial, remember monomial means one term, and multiply by a binomial, we distribute. And so remember, binomial means 2. So because we have the same radical, whatever is underneath, we can actually multiply. So when we were doing the adding and subtracting, we were not allowed to add or subtract what's underneath the radical. But we can do that when we multiply or when we divide. So that's a property that we are able to use. So when I do 3 times 6, I get 18. And then I do plus, because that's my sign here. And then I do 8 times 3 to give me 24. Now I need to continue to simplify, meaning I need to determine is 18 and 24 perfect squares. Well, 18 is not, but the largest perfect square that goes into it is 9. Okay, so we have square root of 9 times square root of 2. Square root of 9 is 3, so we have 3 square root of 2. And then for 24, well, 24 is not a perfect square as well, but the largest is a 4. So we have square root of 4 times square root of 6. Square root of 4 is 2, and then we have square root of 6. Now we do need to decide if we can combine anything more here. Well, because though they have both the same radical, the square root, the 2 and 6 are not the same, so we cannot combine this. So our final answer is 3 square root of 2 plus 2 square root of 6. Okay, I would like you guys to go ahead and pause the video and try number 8 for me. Okay, let's see how you did here. Okay, so with square root of 10, I'm going to distribute that to the square root of 5 and to the square root of 4 square root of 2. Now we do, once again, as we said, with multiplication, whatever's underneath the radical, as long as the radical is the same, so they are both square roots, we can do multiply. So 10 times 5 gives me 50, so that's square root of 50. Now be careful here. Notice we do have a 4 that is outside the radical. So we really can't do 4 times square root of 10 to give us 40, because the 4 is outside the radical while 10 is not. But what we can do, so we'll have plus 4, what we can is, because the 2 is underneath the radical, is multiply that with the 10. So I can have 4 square root of 20. Okay, now if you're kind of struggling with that, go ahead and pause the video again and simplify all the way. Okay, let's see what you got here. So 50, is that a perfect square? No, it is not. So we know the largest perfect square that goes into it is actually 25. So square root of 25 times square root of 2. We know square root of 25 is 5, so I have 5 square root of 2. Then, don't forget, make sure you bring down this 4, so we have 4 times. Now, is 20 a perfect square? No, it is not. But what's the largest perfect square that goes into it? That is going to be 4. So I have 4 times square root of 4 times square root of 5. So now I have 4 times, I do square root of 4, gives me 2. So I have 4 times 2 times square root of 5. Now let me go ahead and multiply the 4 and the 2. So I have 5 square root of 2 plus 8 square root of 5. Can we combine these two? No. Since the numbers underneath the radical are not the same, then these are not like terms, so therefore we cannot combine, and this is my final answer here. Okay, let's go ahead and do the next one. So now, notice that we have 2 binomials. This is where we're going to FOIL, okay? So we have 3 plus square root of 5 times 3 minus square root of 5. So remember to FOIL, I'm going to take my 3 and multiply by the first and second term. So notice that the 3 is outside the radical, and the other 3 is also, so we can multiply that. So we do 3 times 3 gives us 9. But when we do 3 times square root of 5, since the 5 is underneath the radical, I can't really do 3 times 5 to give me 15. Instead, I will keep the 3 on the outside of the radical. Notice we are multiplying by a negative square root of 5, so minus 3, and then I keep the square root of 5. Now, I take my square root of 5 and multiply by 3 and square root of 5 again. So just like the last time, since 3 is outside the radical and 5 is inside, I can't multiply them to get 15. Instead, all I can do is keep the 3 before the square root of 5. Notice my square root of 5 is positive, so I have 3 square root of 5. Then I'm going to do square root of 5 times negative square root of 5. Well, both 5's are underneath the radical, so then I can multiply to give me 25. I do have a negative, so don't forget that sign, so I have square root of 25. Okay, let's see if we can combine or simplify anything more. 9, I can't combine that with anything because there's no like terms with it. But notice that my negative 3 square root of 5 and positive 3 square root of 5, they are like terms. But what happens to them? They do cancel out, okay? Now, let's look at the square root of 25. Is 25 a perfect square? Yes. So square root of 25 is 5. Now, make sure you have that minus because that is before the square root of 25. So now 9 minus 5 just gives me 4, and that's my final answer. Okay, I would like you guys to go ahead and pause the video and try the next one. So try number 10. Okay, let's see what you got here. So here we are once again foiling. So I'm going to do the same thing. I'm going to take my 6, multiply by the 2 and negative square root of 2. Well, 6 and 2 are outside the radical to give me 12. But the one inside the radical, I can't multiply it with 6 to give me 12 again. Instead, I can only write negative 6 square root of 2. Now I do the next one, 5 square root of 2. Okay. Now be careful. So with the 5, since that's outside the square root, I can multiply with any other numbers outside the square root, which will be the 2. So that will give me plus 10. But that square root of 2, I just have to keep it the same because I can't multiply with anything else. Okay, now I multiply 5 square root of 2 with negative square root of 2. So 5, there's no other numbers outside on that negative square root of 2 to multiply with, so I keep I do minus, because I have negative square root of 2. So I have minus 5. Now my square root of 2's, because both of them are underneath the radical, I can multiply to give me square root of 4. Okay, let's see if we can combine any like terms and cancel things out. Okay, 12, I can't combine it with anything because there's no like term, so I just bring it down. But my negative square root of 2 and 10 square root of 2, because they have the same radical and the number underneath is exactly the same, I can go ahead and combine like terms. So I do negative 6 plus 10 to give me 4, and that's square root of 2. Then I have negative 5. Now is 4 a perfect square? Yes, square root of 4 is 2. So I do actually negative 5 times 2, you gotta multiply. So I go ahead and do that. So now I have 12 plus 4 square root of 2 minus 10. Notice that my 12 and the negative 10, they are just integers. So I can go ahead and combine them because they are like terms. So that gives me now 2 plus 4 square root of 2. Okay? And now I can't simplify anymore, so this is going to be my final answer. Now, as I said, like in the adding and subtracting radicals, make sure for your homework assignment, what's going to happen is you're going to have these dashes. Now, if you see the dashes looking like this, that means how you're going to plug this in is the 2, that is the integer, goes in front, and we have the 4 and the 2. However, if the dashes look like this, okay, that means we would actually have 4, then the 2, and the 2. So what I'm just saying is that, remember, you can actually rewrite your answer any way. So you can do 2 plus 4 square root of 2 or 4 square root of 2 plus 2, okay? Now, you just have to kind of look at the homework assignment to see where the dashes are so you know where to plug the numbers in. Okay, we're going to do our last final one. We have 4 square root of 3 minus square root of 2 squared. Now remember, we're dealing now with exponent rules. Notice we have a subtraction sign in between our two terms. Remember, anytime we are adding or subtracting, you cannot combine or you cannot distribute the exponent. Instead, this is what we did in our polynomials and really quadratics unit. What this squared means is we're going to expand. So I'm really going to do 4 square root of 3 minus square root of 2 and multiply that with, once again, 4 square root of 3 minus square root of 2. So what I'd like you to do is go ahead and pause the video and try this one on your own. Okay, let's see what you got. So I multiply 4 square root of 3 by itself and negative square root of 2. So 4 times 4 gives me 6. Square root of 3 times square root of 3 gives me square root of 9. Now I do minus, I keep the 4, because I can only do square root of 3 times the negative square root of 2. That gives me square root of 6. Now I'm going to take negative square root of 2 and multiply it by 4 square root of 3. This is going to be the same thing, so I have minus 4, and I can only do square root of 2 times square root of 3. That gives me square root of 6. Remember, I can only do that because the 2 and 3 are underneath the radical. Then negative square root of 2 times negative square root of 2. Well, 2 negatives make a positive, and remember I can multiply, that gives me square root of 4. Now, let's go ahead, let's combine like terms if we can, simplify all that stuff. So looking at the first term, we have 16 square root of 9. Is 9 a perfect square? Yes. So what I'm going to do is I'm actually going to do 6, and I'm taking the square root of 9, which is 3. Remember, we multiply here. Now, notice I have like terms that I can combine. It's the negative 4 square root of 6. Okay? They both have the same radical, and the number underneath is exactly the same. So I can go ahead and combine the coefficients, so the negative 4s. So negative 4 minus 4 gives me negative 8. And so I'm going to have negative 8 square root of 6. Now, my last one is the plus square root of 4. So I do plus. Is 4 a perfect square? Yes, it is 2. Now I'm going to go ahead and multiply the 16 times 3. And you can just plug that into your calculator. I get 48. So I have 48 minus 8 square root of 6 plus the 2. And notice my 48 and 2, they are like terms because they're integers, and I can combine them. So I get 50, and then I just bring down the minus 8 square root of 6, and this is going to be our final answer. And remember, you can also write it as negative 8 square root of 6, and then the plus 50. Just make sure that 50 is not inside the square root, okay? So both ways are acceptable to write your final answer. Okay, make sure you guys work on the homework assignment. If you do have any questions, make sure that you contact me. I'll see you guys later.